Hello everyone. It looks like everybody's about on and has joined us. So we're going to go ahead and get started. Hopefully you had time to watch the YouTube video and you know that we are going to be talking about polynomials. So what I have here for you is an example of two of the same types of polynomials that you can see in the real world every day. So to get started and really start talking about polynomials, we're going to start talking about the classifications of polynomials and how to classify them. So first, we're going to look at different classifications in life, some things we're already familiar with. So animals, for example. Bears, there's polar bears, which are usually white in color, and brown bears, which are usually brown in color. You can also classify animals as horses. There are brown horses. And you can even farther classify those by their different breeds. And then there are also white horses, which can also be further classified by their breeds. So you can see how things can be grouped or classified. So just like the classifications in life, we can also classify polynomials. So, a little bit of a review. What does it mean to combine like terms? So if we have 3x plus 4, if we combine those terms, we're adding them together to get 7x. The next one, if we have 5x squared plus 3x squared, what would we get? Stacy. Right, 8x squared, because we would add them together and we're combining them. The next one, if we combine the like terms here, what would we have? Steve. Okay, don't forget, we're subtracting x. So we have 6x plus 10x squared. Good job. So like terms are terms with the same variable raised to a power, which we should be familiar with. And then to combine them, we would add the coefficients, but we keep the variables the same, so we don't change anything with the variable. But what if we can't combine like terms? In this example, we can't. So we would just simply put the coefficients in descending order, but don't forget they carry their signs. So this is what this looks like in descending order. And this is called standard form. So this is actually a polynomial in standard form. So what exactly are polynomials? They're a sum of terms that has variables that are raised to whole number exponents. So here's an example. And quadratic in this context just means the second power. Classifying polynomials by term. So coefficient, again, we should be familiar with what this term is, but the number that's being multiplied by the variable. So example 5x, so 5 would be the coefficient. And polynomials can be classified by the number of terms that they have. So we have a monomial, which is one term, like 4x. A binomial, which has two terms, like 4x minus 3. A trinomial, which has three terms, like 2x squared plus 4x minus 3. And any term with 4 or more terms is actually just called a polynomial. So questions. What is the sum? A sum of terms that has variables that are raised to whole number exponents. Emma. Right, a polynomial. We just went over it. So are there any other questions about this section before we move on to the next? Stacy. So Stacy says, can they be classified by more than one classification? So the answer to that is yes, and we'll be talking about that as we move on. So the next way they can be classified is by degree. So the largest exponent. So we have first degree, which you should be familiar with, that's called linear. Second degree, which is called quadratic. Third degree, which is called cubic. Fourth degree or quartic. And fifth degree or quintic. And polynomial equations of a degree greater than 5 are not solvable by methods other than approximations. So in standard form, we just talked about this. You would go from largest exponent to smallest exponent. And this is not in standard form because our largest exponent is over here. So more questions. So is the following polynomial in standard form? Let's see who we can call on here. How about John? No, it actually is because we have from the largest exponent to the smallest exponent. So any other questions? So John asks, is it okay to not write a polynomial in standard form? Well, there's nothing wrong with not writing it in standard form, but we do that because it makes them easier to work with. And then, oh, Steve says, you went too fast and I didn't get my notes all filled in. So the notes worksheet that you should have opened in the beginning, that was on the first slide, he said he didn't get it all filled in. So we're going to kind of go over that here in just a second anyway, so it's okay. So here's the top of your notes worksheet. So the definition of the polynomial, this is what you should have. And then this is terms, like the picture in the previous slide. And then the coefficient is the number that is multiplied by the variable, the number in front of the leading term, leading coefficient. And then polynomials, can we classify the number of terms they have? A monomial is a polynomial with one term. A binomial has two. A trinomial has three. Degree, and for this example up here too, you can have anything. I mean, I put one in there. As long as it's a binomial, you can have anything there. First degree is linear. Second degree is also known as quadratic. Third degree is cubic. Quartic is fourth degree. Standard form. And then there's one, this one has to be this though, because this is the example, not in standard form. So this is what it would look like in standard form. So we're going to go ahead and do some practice now. I'm going to go over one with you and then ask you to answer one as well. So is it a polynomial? So this is to a negative exponent. So because it's a negative exponent, it's not a polynomial. Okay, what about the next one? Andy. Right. This is a polynomial, but it's not in standard form. But the question wasn't that good. The next one. So this one, I'm going to go ahead and answer this one. It is to a half. So it's not, because it has a fraction exponent. What about this one? What degree polynomial is number 2? Emma. Cubic or third degree? Third degree, yes. How many terms does it have? Steve, let's go ahead and have you guys do this one. Right, it's just a polynomial because it has more than 3 terms, right? Good job. So a little more. What is the standard form for these ones? You're going to say, what's the standard form? What's the polynomial's degree? How many terms does the polynomial have? And what's its name? So this first one, I'll do for you. The answer is written like that. A second degree quadratic, has 3 terms, and it's a trinomial. Number 2, John. What do you think this one is? Okay, that's how you write it. Yep. And it is first degree linear. Good job. And it has 2 terms, and it's a binomial. Good job. The next one. Let's have someone else do this one. How about Steve? This one's a harder one. So that's how you would write it. Good. It's 5th degree quintic. It has 6 terms and it's a polynomial. Good job. That was a hard one. Okay, so here we're going to talk about linear polynomials, which this should really be a review from Algebra 1 for us. Okay, so roots are just values of the variable that cause the polynomial to evaluate to 0. So we're looking for where they cross, here's our axis, where they cross the x-axis, okay? So Algebra 1, the slope-intercept form is y equals mx plus b. And we're going to solve for where y equals 0. So this is a linear binomial. We're going to put 0 in for y, and we solve, and we get to x is equal to 2. So we have one root, and our intercept is 2, 0, where it intersects. If we set x to 0, we can find the y-intercept as well. So without a graphing calculator, we should very easily be able to graph this with the 2 points. So that looks like this. And you can see right here, it intersects in one spot. And what do we notice about that? Well, what we notice is that there's this exponent here would be a 1 technically. We just don't put it there. But it would be a 1. So the degree of the polynomial is the same as the number of roots. So for the next one then, so this is, and also I use Desmos.com to graph this, and it's a really good resource when you're doing things virtually or online if you want to try to show your graphs. So now I'm going to have you guys, this is like the shape we saw. I'm going to have you guys work through this one with me. It is just upside down. So in the pictures in the beginning, they were more like this. This one goes up instead. So this is a common polynomial. It's called a parabola. And what we need to know is how many roots does this have? So we look, where does it cross the intercept? It crosses it in 2 points, right? So it would have, Stacy, 2 roots. Good job. And this one, even a little trickier here. So this one's raised to the 3rd power. So how many roots does this polynomial have? John? Not 2. But 3. So this one's tricky because it crosses right in the middle here. So we have at the vertex, so you have 1, 2, 3. So it actually crosses in 3 different places. All right. So what you're going to do next is you are going to work on some independent practice. For right now, what we just talked about with roots, we just want to know how many roots, okay, not the actual root itself, because when we start talking about, in the next lesson, we're going to get into how to solve for roots for something a little more complicated than the linear equation. So what you're going to do for the independent practice is open your lesson 1 worksheet. And you're going to work through some of these problems yourself. I will be available, but to help you after this, it will be due the next class and we'll have a quiz. So you're going to work through the problems, and then, like I said, I will be available. Any other questions? Andy asks, do we need to list the roots on the worksheet? So I just said we don't actually need to list the roots. Themselves, just list how many for now, because you're not going to be able to solve for the ones that are not linear. So we're going to have to work, we'll go over that in the next lesson. So, okay, well, thank you very much, and have a good rest of your day, and I'm available if you need me. Thank you. Bye.